Okay, and for number 18, it's asking for a nonpolar molecule that has polar covalent bonds. So, which one of these is nonpolar with polar bonds? So right away, if it's a polar molecule, you can eliminate that. So remember that polar is only one line of symmetry, and nonpolar is two or more. So in our case, we start with A. We have a line of symmetry here and here. That's at least two. CO2 has these lines of symmetry, but C and D only have lines of symmetry, only one, so can't be C or D. Now we're looking between A and B and which one has polar bonds. Well, if you think about, for bonds, we have to think about electronegativity differences. Well, hydrogen is going to have the same, which gives us electronegativity difference of 0, which represents nonpolar. So in our case, it's B, but you could also check with electronegativity differences. O is 3.6, carbon is 2.4, 3.4. Hold on, I have those backwards. The 3.4 minus 2.6, which gives us 0.8, which is in fact polar. Okay, which represents a polar molecule? Again, lines of symmetry when we're talking about polarity of molecules. 1, 2, nonpolar. 1, 2, nonpolar. This one has a bunch. Definitely not nonpolar, which leaves us with water, which we know is a polar molecule and only has one line of symmetry. Which one of the following structures is a pyramidal shape? Now, this one's a little tricky because you know for pyramidal it has to have 4 atoms, so it can't be B or C. And I wouldn't do this to you on the test, but the answer is D, because A is technically trigonal planar versus D kind of gives more of that raised look we're going for here. And we hadn't talked about VSEPR theory, but the answer here is B. The reason why the atoms are the way they are has to do with the fact that the electrons in the bonds don't want to be by each other. This is why in all of the shapes we've discussed, notice how the atoms are as physically far away from each other as they possibly can be. This has to do with the repulsion of the electrons in the bonds. Base your answers to the following, given the information. So, if we have something that has a low melting point, likely not ionic, nearly insoluble in water, likely nonpolar, electrically non-conducting, probably covalent. So, the type of bonding we'd expect is covalent. In terms of attractions, well, if it has a low melting point, that means it has weak intermolecular forces. Explain why the particles of this substance are poor conductors. Well, they must not be freely moving. That's what you need to be a good conductor. And charged. Number 23. So if we have a low melting point, again, likely covalent. So both these lead towards me thinking it's covalent, because being a non-conductor means it can't be ionic. Nearly insoluble in water, again, nonpolar. So the type of bonding, covalent. Why is the substance insoluble? Because water is polar and substance is nonpolar. Because remember, like dissolves like. And this was kind of a weird question, but thinking about why it could have a detectable odor, the reason being is that if you have a covalent nonpolar molecule, its intermolecular forces are weak, that the molecules don't want to stay next to each other. This leads to volatilization, which is what would give us a detectable odor. So it has to do with weak IMF. For 24, we have a high melting point and a conductor of electricity when dissolved in water. So that's going to lead me to believe that it's ionic. If it's soluble in water, it must be polar. And so our case, state the type of bonding. Well, it'd be ionic. Why it conducts electricity is, or sorry, this would be, well, polar ionic, that's fine. Both are fine. Explain why the substance conducts electricity. Well, it has to be with ionic, which means freely moving charged particles. And just like the other one, talking about odor, this is just the opposite. Why it would have no odor has to do with high intermolecular forces. Now, when the intermolecular forces are high, the molecules do want to stick together, so they stay as a solid versus volatilizing into the air. And so that is the end of your review packet. Please send any emails about questions that you may have. Good luck.